Okay, so here's how you calculate the equilibrium constant when you have some of the concentrations. At a certain temperature, a mixture of hydrogen gas and iodine gas was prepared by placing 0.1 moles of hydrogen and zero point 0.1 moles of iodine into a 1-liter flask. Using colorimetry, it was determined that the concentration of the iodine had dropped to 0.020 molar. Find the equilibrium constant for this reaction. Okay, so first things first, we have to address the molarity. Okay, so let's remember that molarity is equal to the moles divided by the liters. So in this case, we have 0.100 moles of hydrogen in a 1-liter flask. So if I divide these, I end up with a molar concentration of 0.100. So in this case, it's the same, right? Since we have equal number of moles, both in the same number of flasks, then we can assume that iodine has the same concentration, which is 0.100 molar, okay? Okay, so here is our equilibrium. It's been established. Hydrogen reacts with iodine to form 2 moles of hydroiodic acid, right? So in order to make these calculations, what we need to do is we need to set up our ICE chart, okay? ICE chart stands for initial concentrations in molarity, changes in concentrations in molarity, and the concentrations at equilibrium, right? So if you take the first 3 letters, you get the ICE. Now, how do we set this up? Well, we already know the molar concentration of hydrogen and iodine, right? That was given to us in the question. We just calculated the molarity here. So all we got to do is input that value. So for hydrogen, we know it's 0.100, right? The molarity is here, so I'm not going to put the units in the chart. Iodine is also sitting at 0.100 molar concentration. And before the reaction happens, the concentration of the products or the hydroiodic acid should be 0.00, right? Because the reaction hasn't happened yet. Okay, so we see here, right, according to this, that this question, that the concentration of the iodine dropped to 0.020. So if I'm sitting at 0.100 and I drop by some amount to get to 0.020, then that amount should equal 0.8080, right? So basically, what's happened from iodine is that it went from a concentration of 0.1 to 0.02. So what that means is that this decreased by 0.80 moles in the process of the reaction happening. Okay? Now, because it's 1-to-1 ratio with iodine gas and hydrogen gas, that means that if 0.080, let me go ahead and correct that. If 0.080 decreased for the iodine, right, then that means an equal amount had to decrease for the hydrogen, because for every 1 atom of hydrogen or mole of hydrogen that we have, right, we're using 1 mole of iodine. So those are going to experience the same amount of change, right? Now, as we go to the products, now we begin to see products forming. So because there's 2 moles for every one of those being used, then this is going to change in the positive by the same amount, right? It's going to change in the positive by the same amount, because as these 2 atoms come together to form this compound, you're basically using up the same amount, right? So whatever decrease you have in the reactant side, in this case, you should see the same increase on the product side. Now, the only difference is this 2, because it is a 2-to-1 ratio. See, there's an imaginary 1 here and there's an imaginary 1 here, so the stoichiometry does play a role. Okay, so Once we have the changes to our concentrations, then we establish the concentrations at equilibrium. So how do we do that? We just do the mathematical operation. So 0.1 minus 0.080 is going to take us to 0.020, 0.020, right? And then it's going to take us here 2 times 0.80 at 0.160. Remember that when this reaction is happening, the products are being formed and the reactants are disappearing. So it makes sense that the reactants are going to have a negative value and the product is going to have a positive value because these products are forming. So with this simple setup, now we understand, or now we know our molar concentrations at equilibrium. So what does that mean? Well, once we have our concentrations at equilibrium, then we can set up the mass action equation, right? So if I take a look here, right, at our equation, which is H2 plus I2 produces or yields 2 moles of HI. What that means is that the equilibrium constant, or the mass action equation, is going to look like this: products over reactants. Even though these are in gas state, right? Remember that we are given the molar concentrations, not their partial pressures. So we still use this mass action equation here, okay? Once we have our mass action equation set up, then all we got to do is plug in our values. So the equilibrium constant here is going to equal to 0.160, right, squared, divided by 0.020 times 0.020, which when all worked out gives us a value of 64. And that's it. That's how you calculate using the ICE chart when you don't specifically have all of the molar concentrations for the equation, right? Sometimes you have to figure those out. If you have any questions, go ahead and let me know.